Okay, in this video, we're going to be doing Calc AB Problem Set 39. The problems and a playlist are in the description below, and let's see what the problems look like. Number 1, use a sign chart for f prime, the derivative of the differentiable function f. There's kind of a problem here. Differentiable implies continuous, but is it differentiable? I don't know. I feel like we don't actually know that this function is continuous everywhere because, for example, 3 could be a vertical asymptote and you could still have a differentiable function because it doesn't say differentiable on the real. So this is not a thing that we need to worry about here. But if I'd written a better problem, I would feel better about it. Anyway, use the chart above to answer the questions. All right, A, what interval is f increasing and justify it? So looking at this thing, increasing will be when f prime is positive. So f prime is positive when x is less than -2 and greater than 7, between 7 and 12. So I'm just going to write that down. F is increasing on x less than -2 and 7 less than x less than 12 because f prime is greater than 0 there. Perfect answer. Move on to the next part. State and classify the critical points of f. So again, this is the thing where I was worried before. We don't really know that this thing is continuous or exists at -2, 3, 7, and 12. We don't know. We do know if it does exist, then it is continuous because it's given that this is differentiable. But whatever, we're going to answer it like all of these values exist in the domain. That's what we're going to do. So the critical points are definitely -2, 3, 7, and 12 because they're on our sign chart. I don't really like this problem. I don't know if you're picking up on that. So those are our critical points. And then we're looking for relative maximums, right? So that's where the derivative goes from positive to negative. So at -2 and 12 that happens. So let's say f has relative maximum at x equals -2 and x equals 12. And then let's give a reason. So we'll say because f prime changes positive to negative there. And then relative minimum would be where you change for where f prime changes negative to positive. And that is only happening at 7 because 3 is one of those weird points where you go decreasing to decreasing. Might be a point of inflection, might be a vertical asymptote. We don't have enough information. But f has a relative minimum at x equals 7, and let's give a reason, because f prime changes negative to positive there. All right, let's get past this problem. Number 2, a particle's position is x of t equals e to the 3t sine of 2t. Is speed increasing or decreasing at x equals 5 pi over 6 and justify? I kind of regret the choice of function that I made here because we're going to need to find the second derivative, but let's find the first derivative before we complain about that. So, well, that's everything. I'll walk you through it. So v of t is x prime of t. You have to connect them. And then we're going to do a product rule. So it's first, derivative of the second is going to be 2 cosine of 2t. Second, sine of 2t. Derivative of the first is going to be 3e to the 3t. So if we only needed velocity, I would not clean this up at all. But we also need to find acceleration. So I'm going to clean this up so that finding acceleration doesn't involve multiple product rules. It's just one product rule. So I'm going to take e to the 3t out. And that'll leave me with e to the 3t quantity, 2 cosine of 2t plus 3 sine of 2t. Now I need to plug in 5 pi over 6. So v of 5 pi over 6. You're definitely getting e to the 5 pi over 2. That's definitely positive. You get the cosine of 5 pi over 3 is 1/2. The sine of 5 pi over 3 is negative root 3 over 2. So we have 2 times 1/2, which is 1, and then plus 1.5, which is 3 over 2, times negative 0.8. So then you have to ask yourself, which of those is bigger? It turns out that this is negative for sure. I did use a calculator to check that. I think you could work it out. I just didn't feel like doing that. That's kind of a theme with me on these problem sets where they are for practice to show you the skills. I'm not really here to do arithmetic. I don't know if I'm just making excuses, definitely kind of. All right, we got to find the second derivative. So a of t is v prime of t, or x double prime, whichever you want to do. Product rule again. So first is e to the 3t. Derivative of the second is going to be -4 sine of 2t plus 6 cosine of 2t. So that's first derivative of the second, and then plus second, which is we already have, so you don't have to think about that much. Derivative of the first is just 3e to the 3t. Then we need to evaluate this thing at 5 pi over 6. And I'm not going to clean it up, but I am kind of cleaning it up. So what I'm going to say is that a of 5 pi over 6 is going to give you an e to the 5 pi over 2 again. And then, all right, so how many sine of 2t's are there? Well, there's this -4 and this 3, but it's not actually 3. It's really 3 times 3, so there's 9 positives and 4 negatives, so 5 positives overall. And then the sine of 5 pi over 3, again, is -√3/2. And, all right, how many cosines are there? There's apparently 6 and 2, but there's not really 6 and 2. There's actually 6 and 3 times 2, 6 and 6. So there's 12 of them. So 12, and then we needed the cosine of 5 pi over 3, which is 1/2. So this is more obviously positive in my mind. I don't know. I think it's more obviously positive. So that's going to be greater than 0. And then velocity was negative, acceleration was positive. So since v of t is less than 0 and a of t is greater than 0, the speed is decreasing, which is all we needed to do. That's our justification. I mean, the whole thing is required, but I think of that as my justification. I don't really know. Maybe the work is the justification. I always do both when someone says and justify, so like I'm not sure which one they're really looking for. All right, next problem. Given f of x is x minus 3 over x plus 4, on what interval is f of x both increasing and concave down? So we're going to need the first derivative and the second derivative. It's kind of a neat way to find this derivative, but I'm going to just do it by the quotient rule. While you watch that, the neat way to do it is to add and subtract 4 from the numerator. So you'll have x plus 4 minus 7. And then you have x plus 4 over x plus 4 is 1. And you have minus 7 over x plus 4. So you're really just finding the derivative of 1, which is 0. And the derivative of -7 over x plus 4, which is -7. The quantity x plus 4 to the negative first. Power rule gives you positive 7, x plus 4 to the negative second. When we clean up this, we also get 7 over x plus 4 squared. So that's called the +1 -1 trick. I have a video about that. I use it in a lot of my videos. It's like a fast way to find some derivatives. With a little practice, you definitely get it. So now to find the second derivative, think of this as what? 7, the quantity x plus 4 to the negative second. I'm not really sure if I found the second derivative or if I started making a sign chart first, but whatever. We're going to bring down the -2, get -14, x plus 4 to the -3. Oh, I did. Okay. So here we go. So I'm thinking of it as 7, quantity x plus 2 to the negative second. Bring down the exponent gives you -14. Subtract 1 gives you -3. Rewrite it like a normal person. Because if you're going to work with it, you don't want negative exponents. If you're not going to work with it, negative exponents are totally fine. If you're just going to sub in something, negative exponents, not a problem. But here I need to make a sign chart. I think it's better if I, simplify it. So sign chart for f prime. F prime is always positive, except at -4 where it does not exist. Because you're squaring, right? You have positive divided by positive. And then for f double prime, to the left of -4, so like -1 billion, you get a negative on the top, you get a negative on the bottom, so positive overall. And then it switches when you have a positive. You'll have a negative divided by a positive, so negative overall. We're looking for increasing and concave down, which means f prime is positive, which is everywhere. F double prime is negative, which is x is greater than -4. So I'm going to say f is increasing concave down on x greater than -4 because f prime is greater than 0, while f double prime is less than 0 there. That's the problem set. I hope you found this helpful, and good luck.